First of all, I'll be talking about QML, best practices for the most part. I'll also briefly talk about the new CMake API and qmllint.
And I'll be talking about QQuick, specifically layouts, controls, and some miscellaneous tips.
All right, let's start off with the QML section first. So the first important thing is to use declarative registration. Instead of using the QML register functions, use declarative macros. Those have been around since 5.15. And you have to use some alternative macros that map to previous imperative calls. So when you would have used QML register type previously, use QML element or QML named element if you want a QML type name that differs from the class name. For singletons, you would use QML singleton instead of QML register singleton type. And for uncreatable types, you would use QML uncreatable in combination with QML element instead of using QML register uncreatable type. This is needed for tooling and compiler support. And it's much cleaner than having a list of registration calls somewhere. So you can instantly see which classes are exposed to QML and which aren't, and also whether this class is exposed as a singleton or an uncreatable type, and so on. This slide only covers a fraction of what you can do with declarative registration, so make sure to check out our docs, which have much more details on this. So let's get to the meat of the best practices. The first thing is use required properties. So required properties have been a thing since Q 5.15. They verify that a property that you rely on being set does get set. This can be done both for new properties. For example, here we have a component that defines a new property called price and marks it as required. But it can also be done if you have an existing property. So here, for example, we have a text element and we mark the property color that's already been defined in text as required. This is useful to let all the users of your components know at compile time that a property needs to be set, instead of producing errors at some other point when something ends up as undefined when it shouldn't be. It's good for use in delegates. We'll see some examples for that. And it's important for passing around information without relying on unqualified access. So let's talk about that. Unqualified access. Unqualified access is whenever you're referencing a property outside your current component scope without clearly specifying which parent component it belongs to. If that confuses you, don't worry, we will see many examples that will illustrate what exactly unqualified access is and what it can look like in various instances. There are several problems with unqualified access. One of the most obvious problems is that it comes with a performance penalty, because the engine will have to iterate from the component your references in all the way to the root component in the worst case. So if you're, for example, referencing a property in your application window and you're down in some button that's nested deeply inside of a big UI application like a car dashboard, the engine will have to iterate through all these parent scopes until it gets to your property, and it might have to do that several times until it gets cached. So that's one of the reasons you should definitely avoid that. It's also a maintenance burden and makes promises about components outside the documents which cannot be kept. We'll see some examples of that too. And it causes issues with tooling, like limited analysis with qmllint, which we'll talk about a bit later. And it will not compile using a new QML compiler. So that might also be a reason why you want to avoid it. So let's see that first example to make it a bit clearer what we're actually talking about here. Here we have an example component where we have a rectangle component at the root and then a text component which references a property of that rectangle, namely font name, and both as the font family of the text and as the text. So this is something that you would probably have like in a font picker or something like that. Now, if you want to do this without unqualified access, you'd ideally give your rectangle an ID, root here because it's the root component of this document, and you also prefix your font name access with root dot to make clear where it's referenced from. This is preferable to writing parent dot because you could have like multiple new component layers added, because let's say there would be another rectangle in between, and your references would still work. While if you just use parent dot, those would actually break. So let's talk about a bit more complicated case. For example, here we have a button that's supposed to enter full screen, and the onClicked handler calls main_win.show full screen. We have an explanatory comment here, which you would probably not have in real life, which says main_win is the ID of our main application window somewhere up the component tree. So how would you write this ideally? Ideally, you'd use a required property instead that asserts that you have an application window called main_win, and this has several advantages. One of the biggest advantages is this will actually be enforced. If you don't pass a property, if you don't pass an application window into this button, it will tell you at compile time, hey, there's something wrong. If, however, your main_win window ID somehow changes, it will just break once you click the button, which you might only catch in testing later down the line, which is very annoying. It also protects you against the type of main_win changing because it's actually defined here. So if the type changes, you will also get warnings. While if you just rely on this ID here, main_win could turn into anything else, and you'd be none the wiser until something breaks. And usually, like here with a button, it's when the unClicked handler is triggered, and that's something that you might not test every time you make a change to your application. So it's better to use a required property here because you'll see that it breaks instantly instead of breaking silently later down the line. So let's talk about referencing properties from C++. So previously you might have code like this. We have an application window here, and when it gets completed, we initialize our backend. And we also have an explanation here that backend is a context property of our custom type backend, and it's set via setContext property. Now we can improve this by, again, using required properties to require this property backend being set. So now we actually know, okay, there is a property backend and we know its type. While here, the only explanation of what backend is and where it comes from is actually this comment, which in many actual applications, you won't see an explanatory comment. You will just have to infer that backend is coming from somewhere. So this also has the advantage that it will warn you if you don't pass the backend property in there. You won't get an error that this is undefined at some point if this is called, but the initialization itself will fail and say, hey, you need to set backend. Now this also requires a change on the C++ side. So previously you would have your application engine, your backend, and then you would load it. And to set the context property, you would use engine.rootContext and then set the context property there as thus. Now this is a bit different. You now use engine.setInitialProperties, which takes a qvariant map. And in this qvariant map, you have to use qvariant from value to actually turn your custom qobject into something that the map can deal with. This will require you to declaratively register backend, but I've already explained why this is a good idea anyway. There's also one alternative to doing required properties for this backend problem. You can use you can turn the property into a singleton. You won't need to pass around the backend property anymore. It will be available from everywhere. So it will look like this. You will still import your module, but instead of referencing a specific backend object, you have one backend object you can reference from everywhere. This is especially great for bigger applications because it will enable you to use the backend property with much less hassle, and you could have a lot of passing around otherwise. Now let's talk about some some less important ones, but less important best practices, but are still nice to keep in mind. For example, here we have a list model with delegates, and here we have a required property again, which is great for delegates. But we shortened this a bit here because this is not our focus. So previously we have this long interpolated string, which is just added with pluses. And But if you actually use templates, this becomes much more readable and much more compact. So use a string template here. This also has the advantage that you can have a multi-line string in here, and it will be much more readable and easier to modify than actually having to keep up with the other variant. Another two new great features that you should use if you can are Nullish, Coalescing, and optional chaining. So let's talk about Nullish Coalescing first. It has been there since Qt 5.15. It works like a logical OR, but instead of checking for truthiness, so whether something is true or false, it checks whether the left-hand side is nullish, so either null or undefined. So if the left-hand side is nullish, then the right-hand side is returned. If it isn't, the left-hand side is returned. Optional chaining, which has been there since Qt 6.2, so it's a new feature. It can be used with property accessors, calls, and array subscripts. And if the previous member of a chain is nullish, so null or undefined, it will jump to the end of that chain and return undefined. We'll see an example of that now. So previously, you might have code like this. This text is supposed to display how many years a vehicle has been owned, but this is in a structure where we can't be sure whether vehicle.owner is actually set and whether vehicle_owner.yearsOwned is set. So previously, you might first check if vehicle_owner is actually set, and if it's not set, you just display non-applicable. If it is set, you have to check again, okay, is vehicle_owner_yearsOwned actually there? And if it's not, let's just display non-applicable again. This has several issues. One of the more obvious ones is that we duplicate this translatable non-applicable string here, which is kind of annoying. And another more subtle issue is that you might have years owned be 0 because it's an integer and maybe the car has just been bought. So this is an edge case which isn't immediately visible if you use OR like this. So let's now talk how you can more easily write this using Nullish coalescing and optional chaining. So now we have our first optional chain here. We have vehicle.owner, and then we have our optional access. And this means vehicle.owner can be null or undefined, and this will not cause an engine error when you access the next property. Instead, it will jump to the end and return undefined. So if this chain were longer at this end, it would still jump to the end, and this could also be longer, and it will behave the same because this is one chain. So the other thing is, if years owned is null or undefined, you'll also just get null or undefined here. And then we have our Nullish coalescing operator, which will return either our years owned if they're actually set, and if it's null or undefined, either because years owned isn't set or owner isn't set, you will get your non-applicable string, which doesn't need to be duplicated anymore. So this will allow you to write much nicer code than before. Another tip is to use qmllint. It started out as a simple syntax checker, but it now automatically checks for unqualified access, type mismatches, and many other issues. There's a blog post out about it on qt.io/blog for more details. And there's a lot of new features that are already in the works for Qt 6.3. So it's actively in development and is constantly being improved. There's the new CMake API also, which you should definitely use if you can. There's no need to write QML manually anymore, which in some cases may not be that difficult, but there are some cases where there's some room for messing up, so it's definitely nicer to have this done for you. You also get automatic caching with QML cachegen. You no longer need to set it up manually. And it gives you a free qmllint target that lints all your files. So for every target, you get an underscore qmllint target that corresponds with it. Will lint all your files, set up all the include paths that you need, and it's much easier than doing that manually. You should read the docs on it. And there are also blog posts available about it on our blog again. And you should also definitely check out the excellent talks that we have about it at World Summit. So check the schedule for that or the recordings if you missed some. So I'll hand over to Mitch now, who will tell you a bit more about the Qt Quick side.
Thanks, Max. Okay, so first thing I want to talk about is layouts. and use implicit size or attached properties to specify the preferred size of your items. So here we have an example of what you don't want to do. We have a rectangle within a row layout, and we're setting the width explicitly to 32 and also binding the height explicitly to parent.height. So the rectangle has no implicit size set, and an attached property wasn't used to set the preferred size. So what happens is that the layout will overwrite the explicit width and height, and the rectangle will be 0 by 0. So the correct way to do this is to use the attached properties or implicit size. In this case, we're using the attached property, preferred width and fill height. And that will make the rectangle fill the row layout correctly. Next tip is to use layout.alignment, not anchors. So for example, here we have another rectangle, but we're anchoring the bottom of the rectangle to the bottom of the row layout. What actually happens here is that the row layout will use its default alignment, which is align vertically centered, and the anchor will be ignored. So the correct way to do it is to use, again, the attached properties. In this case, you want to set layout.alignment to qt.alignBottom. And that will make the rectangle sit in the bottom of the cell. The next tip is to use weights for a responsive UI. So layouts treat preferred and implicit sizes as weights when filling. And by filling, I mean that when you have, for example, here we have two rectangles, both set layout.fillWidth to true. So they're both trying to fill the size of this row layout, but they also have implicit width set to 25 and 75 respectively. So what ends up happening is you have the first one taking up 25% of the width of the row layout, and the second one taking up the remaining space. Here I'm using 25 and 75 just to make it easier to understand, but you can use any values so long as they're proportional. Next subject is style selection. So what is it? It's how Qt controls styles are chosen. So in Qt 5, style selection happened at runtime, but in Qt 6, it can also be done at compile time. So how is it done? The same runtime style selection is done in the way that you're probably already familiar with. You just import Qt controls, and you also use any of these methods. You can set it the style from C++. You can use a command line argument. You can use an environment variable or a config file. When would you use runtime style selection? When your application supports multiple styles. So for example, if you want to support the material and universal style in your application and you want the user to be able to switch between the two, then you would use runtime style selection. When your application is not built statically, we'll cover that in the next slide. And another note about this is runtime style selection can't be fully supported by the Qt compiler because the necessary information is only available at runtime. So compile time style selection. With compile time style selection, you would import the style that you want to use explicitly and then use the types as you normally would. When would you use it? As mentioned, when your application is built statically, or when you only need to support one style. Another advantage of this is that the size of the deployed application will be a bit smaller because the Qt controls plugin is not used, so it doesn't have to be deployed along with the application. And customization. Don't customize native styles. Native styles, the Windows and macOS styles, don't support customization. So if you're using runtime style selection, you need to make sure that you're not customizing and native style. So here we have an example of runtime style selection and customizing the background of a button. This is fine with most styles, but not the native styles. So if you're using, or if you're styling a control from scratch using templates, then you don't need to worry about this. So for example, if you're importing QQuick templates and you're using a templated type as the basis for your customizations, then it's fine. So the next thing is to prefer interaction signals over change signals when available. So here we have a slider whose value property is bound to backend.foo. And whenever that property changes, the backend.foo property will be assigned the value of the slider. The problem with this code is that the handler will be called whenever the value changes, even for programmatic changes. So even if the backend code causes this value property to change, or some other code within this file or elsewhere in the application, then this handler will be called. And that's an issue because it can lead to confusing bugs and binding loops. So what you want to do instead is use the move signal of slider. So the code is basically identical except we're using the move signal, and the result is that the handler is only called when the user actually moves the slider's handle, and not also for any other changes. Next one is don't store state in delegates. So we have a button as a delegate of a list view here, but we're declaring a property within it that we're using to store the state when the button is clicked. You can see on clicked, some state property is true. The issue is that we're storing state in a delegate, and since the delegate can be destroyed or recycled at any point, then the state that we're storing can be lost. So what you should do instead is store the state outside of the delegate. In this case, we're using the model. So when the delegate is destroyed or recycled, then the state is safe. Another tip is to give items object names. So here you can see we have two text fields, both assigned object names. And you can imagine that if this application were to crash and you were looking at a stack trace and the type, the only information that you had available to you is the type of the object, then it could be quite difficult to determine which object caused the crash. So if you give your items object names, then at least if you're using Qt Creator, for example, then the locals window will show you this object name for this type instead of just having a type. It makes debugging a lot easier. Also, if you want to, for example, print the active focus item of the application, if you just print the active focus item by default, it will give you a type name and that's it, which is not very useful. So getting into this habit is good for debugging, but also testing. If you want to do, for example, integration testing, and you want to click a button somewhere within a deep hierarchy within your application, then you need to be able to find that item. And the easiest way to do so is to use the find object function, or find child rather, and that takes an object name. So this just makes your life a lot easier when debugging and testing. Another tip is to use or to make user-facing strings translatable from the beginning. So here we have a tool button, and it's got some tooltip text that is made translatable with the use of this qstr function. So the advice is that you should really try to do this from the beginning of your application, from when you start writing it, because if you have to go through all of your strings and check if they're user facing and then add this, it can be quite a pain depending on the size of your code base. So doing this up front is going to save you a lot of hassle in the long run. And that was it. Thanks for listening. And if you have any further questions, we'll be available in the speakers lounge after the talk.